No, I'm testing, yeah.
Okay. Yeah, wait till I come back up.
Not the area, I think. Come here. Come on in, man.
We do have the setup downstairs. It's apparently streaming for folks again. So, well, if people want to resettle, some people are down in 220. They're just down there waiting for the signal. Okay, we're going to get started. Actually, how many folks have heard of Berkeley Innovation? All right. All right, everybody should have. James is here. He's going to tell us a little bit about it.
So, hi everyone, my name is James and I'm part of something called Berkeley Innovation, which focuses on UI, UX, human-centered design consultancy. So if anyone wants to be a part of this organization, we're having our first info session. We get people coming in from Walmart labs to Westfield malls. They say, hey, you know what, we want you to redesign an experience or something, and we say, you know, we could do that. So we go through the entire design process of iterations, wireframes, prototypes, and then we give them a deliverable at the end of the semester. So we have two branches. We have a general member branch, and then we also have the consultancy branch. So if you want to work on projects to fulfill your portfolio, then you could be a consultant if you apply for that. And then you could also be a general member. You could apply for that also. So either way, we're very selective. So with that, we're looking for people that have a passion and design or in that field. So if you want to be part of Berkeley Innovation, please come to our info session tomorrow at 5:30 here in Jacobs Hall, the same room. And yeah, hope to see you guys there. Does anyone have any questions? No questions. All right. Thanks.
All right, thanks, James. This is a really cool group, so I encourage you, a lot of you, especially if you're interested in design and you're thinking, I like this class, but there's other things. That was your question?
Also, I'm going to leave the flyers up here, so if you want to pick up a flyer after class, they're just going to be somewhere where he lets me put them. So, oh yeah. So, do you mind if I leave the flyers here?
Yeah, that's fine.
All right, they're going to be here.
Okay, great. All right. Sometimes things come up in the class, and like always, sometimes when those are, I like to sort of start with a little reading. We had a passing recently. I don't know if many of you caught this, but Marvin Minsky passed away 2 days ago. Literally a little tiny passage about him. Marvin Minsky, a pioneering mathematician, cognitive science, and computer engineer and father of the field of artificial intelligence, passed away at his home on Sunday at the age of 88. Minsky was a unique, brilliant, creative, and charismatic person, and his intellect and imagination shone through his work. His ideas helped shape the computer revolution that has transformed modern life over the past few decades, and they can still be felt in modern efforts to build intelligent machines, one of the most exciting and important endeavors of our age. Inspired by mathematical work on logic and computation, Minsky believed that the human mind was fundamentally no different than a computer, and he chose to focus on engineering intelligent machines, first at Lincoln Labs, and later as a professor at MIT, where he co-founded the Artificial Intelligence Lab in 1959 with another pioneer in the field, John McCarthy. Minsky's early achievements include building robotic arms and grippers, computer vision systems, and the first electronic learning system that simulated the function of a simple neural network. Remarkably, while at Harvard, he also invented the confocal scanning microscope, an instrument that's still widely used in medical and scientific research. And also, this is a little quote from him when he was a graduate student, and he was trying to figure out, what the heck do I want to do? He said, genetics seems to be pretty interesting because nobody knew yet how it worked, but I wasn't sure it was profound enough. The problems of physics seemed profound and solvable. It might have been nice to do physics, but the problem of intelligence seemed hopelessly profound. I can't remember considering anything else worth doing. So Marvin was much of a Renaissance man in the sense that he was certainly a computer scientist. He was a Turing Award winner. He started doing all kinds of, one of the greatest things was that at a time, you have to imagine this is the 50s, people were talking about computers, and this, you can see it in, when you look back at things even in this class, as it's kind of a computational machine. And he said, maybe it actually could have intelligence. This was really revolutionary, like to think about something that was just doing tabular numbers. He could envision where that field was headed, and he pushed on that. Lots of controversial views as well, but also he had a vision of how that would be radically different. He was also an accomplished pianist. He was he was a musician. He did robotics. He worked on physical devices, and he also looked at sort of co-founding this field of artificial intelligence. So he's a really important figure in the field. You can see him there playing around in his lab with his different machines. And he looked later in his life at education, and he teamed up with Seymour Papert and looked at how computing and intelligence could inform education in really significant ways. There's a book that he was part of, the Society of the Mind, and just a number of really cool endeavors. So there's one quote, I'll read it. Alan Kay, another Turing Award winner, said, Marvin was one of the very few people in computing whose visions and perspectives liberated the computer from being a glorified adding machine to start to realize its destiny as one of the most powerful amplifiers for human endeavors in history. So things like Siri and voice recognition and lots of things in sort of machine learning and computational techniques around learning in general really have lots of their traces of the people that worked on them are have come through his lab or some part of his lab in a lot of ways. So he was older, and so it was a somewhat less surprising. It wasn't as if it was tragic, but still it feels like a great loss in terms of a visionary who had some really profound effect on how we think about computing. He went to the Media Lab, which comes up a lot in this class, and really attracted a huge amount of talent there, where a lot of technology around human-computer interaction happened. So he lured a bunch of people to think about computing in different ways at the Media Lab as well. Okay. All right, I have a couple announcements, and then we're going to talk about wearable computing today. So enrollment, we've basically finalized. I think folks saw that. I put a message out about that. And the backstory, we still over admitted for the class. So I have to make these kind of, it's like a game theoretic where I have to imagine how many people are going to drop. So I've made a secret number in my head that I think is the number, and I've admitted more people than should. So even if you think people dropped, I've already predicted that in my weird model in my head. So I'm not going to let other people in as people drop. So that's kind of what's going on. Also, we now have a really great system, thanks to the GSIs really for leading an effort to set us up with using GitHub in a really seamless way to hand in your programming assignments. I think Jasper's going to tell you exactly what to do. All of this is on Piazza, but he will tell you in person.
All right, hi everybody. Brief announcement. As Professor Paul said, we'll be using GitHub for programming assignments this semester. So all you need to do for now is go on Piazza. There's a post saying like, please fill out this form. In the form, please fill out your first and last name, capitals, like exactly how you registered, because it'll make it easier on us. And then we'll give more instructions Friday section. But the gist of it is everyone will be getting a private repository for their individual assignments, which you can make public at the end of the semester to add as part of your code portfolio. And then we'll also be using team repositories later on in the course. Yeah, so for now, just fill out the form. Thanks.
Questions? Does that make sense? Okay. So this is a great thing. So hopefully this will make things seamless. Just the one key thing also, and there's like, don't log in and set up your account under like GWiz62 OSCI 97. This we will not know who you are. So try to use some naming scheme that's consistent with the class. I also because now your eyes are starting to open and you're encountering bits of technology and interfaces. You might see something online. You might be buying a, balloon ride ticket in the Himalayas, and there's this really interesting kind of kiosk machine. Take some pictures, upload it, just tag it in Piazza, and every once in a while when there's some time, we'll pull some of those and critique them in class and talk about them, and we'll be able to use the kind of context of the class. In terms of programming too, part of that is you have to make a video to document what the final project that you did, the programming assignment. I'll show an example of how to do that in just a minute. That's a forward pointer for me. The other thing is section. So we are taking the sections, and you also probably saw this on Piazza. They are sort of being consolidated into these 5 sections. We've eliminated the later sections, and hopefully this doesn't cause a lot of problems. This will be okay if people cannot make one of these. Of the sections, we're not sort of requiring the section. So if you can't make one of these, we're going to require another mechanism for you to check in that will give you more flexibility. But this matches up much better with the sort of teaching load and also with serving the maximum number of students and a bunch of other things. Otherwise, we end up with one of the sections with like 1 person in it. So you should figure out, one strategy is figure out which one that you are likely to attend. We'll do some load balancing, but you will get to know this GSI as kind of your main report in some sense. This will happen again or in groups, and we have these, you're kind of more lined up with a direct person that will be critiquing your work more. Bring back, prototype something. Just want to say one note on that. I said I would give a little bit more direction on that. So the idea is that you actually want to maybe mock up something on a screen or on some kind of interface, show it to people. So we're not saying, oh, I gotta like mock, I have to build a watch and I have to build this prototype and things like that. You can make it, like I said, out of just paper and cardboard. So here's my watch right here. So cardboard, little sticky note in the middle. So I can draw a little interface, and then I can just, next screen, right? So you can make a little mock-up. This only took a couple minutes. I had a little X-Acto knife, but feel free to use paper or whatever. Mine attaches with this cool clip. Yeah, that's the most expensive part of it that I had to source, but it's a cool watch. Plus, you can talk to people about the future because you have this, like, people go, what's that cool watch? So this is also part of I try to wear a different watch to class every day, so this will be today's. Okay, let me show you a couple examples just to give you some flavor for this programming assignment and documenting it. So we had a very similar assignment last semester. It was not this exactly the same in terms of exercises and calories. The assignment was that you would choose some animal, like say, say from a human to a dog, and you'd figure out how many dog years you are in human years, this kind of calculator back and forth. It's less important how this exactly worked. It's just, I'm going to show you a video from last semester, because if you don't know what that little preface, you'll go, why are we talking about animals? I don't understand what's going on. But what I want you to pay attention to was the requirement was the same. It was in 2 minutes or less, describe the interaction, show us all of the sort of elements of the interaction, and walk us through in a very concise way. A couple things to notice: we're only seeing people's screens. We're not seeing all kinds of backgrounds. We're not seeing your whole background of your room while you set up the camera and all these kinds of things. So we'll just look at a couple because you get a sense of their design choices that they took. They had a very similar setup. It was, here's some animal years. You have to convert between them. Figure out a way to do that.
Hi, this is my Animal Lab. It allows us to convert ages between different kinds of animals, including humans. So for example, to select the first animal that you want to convert from, you select which animal at the top. And here you can scroll through it, and let's say we want to convert from rabbits to OSCE ears. So selecting OSCE at the bottom means that when we enter something like 50 rabbit ears, we know that it's now 11.25 OSCE ears. Now let's say we wanted to select something else. What is 50 groundhog ears in something like wolf ears? Well, we now know that 50 groundhog ears is 38 wolf ears. It's just that simple. You select an animal from at the top, enter the number of ears that animal age is, and select the animal at the bottom, and that's it. You get the number quick and easy on the right side.
Okay, so you'll notice a couple things. Obviously, this could have been done. Maybe many of you started with thinking, well, I could have, you know, some radio buttons and then it'll just come out with a calculation. So this is a lot more visual design put in, a lot more thinking about how to use the screen real estate. Look at another one.
I will be giving a demo of how to use the UAnimal app. UAnimal is an animal age converter. All right, let's get started. So we're at the home screen of my phone right now, and we can get started by tapping the UAnimal app icon right here. So now we see the main screen of the app. On top, we see a card that tells us what the app is and how to use it. So it says to enter age for one of the animals, and then you'll get the equivalent age in all displayed for all the other animals. Let's try an example. So I'm 21, and I want to see how old I am in cat years. So I would tap human because I'm a human, and then I would enter 21, and I would see that if I were a cat, I would be 6.6 years old. As another example, let's say I have a dog that is 7. So I tap dog and enter 7, and I would see that my dog would be 25.5 years old if she were a human. All right, as a final example, let's try this out. So I know that humans live for about 71 years. So if I enter 71 right here, and I look at all the other animals, I could get the approximate lifespan of all the other animals. And here we are. The top card can be dismissed, and also the keyword can be retracted if you want to see more animals at a time.
Okay, so different approach, different visual choices, different way to kind of update everything at the same time. The visual elements could also add clutter, though. You have to kind of consider that. I think I've got one more to give you kind of at least 3 examples.
Hello there. Welcome to Animal Age. Animal Age is a fast and simplistic, surprise animal age converter. When you first launch the app, the default screen shows a dashboard of all the required animals. At the top, you can type the age or choose the animal to convert from. The sentence reads naturally, like how you would speak. For example, if I type 21, it would say 21 human years. Or if I type 1, it would say 1 human year. And the polarization rule also applies to all the cards in the dashboard. In addition, you can also customize the dashboard to include only your favorite animals. Just go to the Action button, go to Add and Remove Animals, and you will see a list of animals that can be chosen from. For example, if I don't like deer, I want to keep only cat, duck, and wolf. I can just toggle these animals on, and when I go back, it would have these animals in my dashboard. And as usual, if I just type in my age, pick an animal to convert from, and answers will be reflected on the cards instantly.
Okay.
The preferences I chose will be saved even after the app restarts.
The saving feature, I forgot.
So if I go to my animals list, pick a few more animals. As you can see, they're in my grid view. I can quit the app and restart it again. They will be here waiting for me. The app also supports landscape orientation, which I cannot show through the video here, but you can check it out on the project website to see the landscape screenshots. Thank you for watching. Bye.
Okay, it doesn't have to be that personal, but okay. So there was another one, I'm not going to show it, but it actually implemented this. It was a little bit funny. You could actually, at the end, you could send messages to your friend. It was just kind of a little strange because you're going to be like, you're saying a text message to someone's like, did you know that like 7 deer years is 5 OSCE years? Like, okay. Are we meeting for coffee? I don't know what this is about. Okay, so I'm not going to do that one. So, yeah. Okay, that's just the visual layout for it. Okay. Okay, I got to turn this down. I know it's buzzing. Okay. All right, so today we're going to talk about wearable computing and wearable technology. One of the, I had this sitting here. So the readings, we have a lot of different readings throughout the semester. There's no textbook required. I would say this is a good one. We already had one reading out of it, and there's another one, and there'll maybe be a couple more, just because it's got a lot about interaction ball was at a certain point, and that would send a signal to the other person. Some calculations would happen. There's no real good floating point on this chip, and then it would vibrate one of the kind of toes inside, and they would know which part of the wheel it's going to land on. They would bet money. So it's a great side project. If you're doing it, just let me know so I can get in on it. But let's walk forward a little bit, because sometimes we think of wearables as only about, you know, the functionality, or we want to look at the guts of electronics. And there's a lot about fashion. It's a lot about how you feel wearing things, how you express yourself. This is an art piece, the electric dress, which that's what it looked like with the artist wearing it. This is it kind of in color. So this is very cool. I would totally wear this. This could be my next Halloween costume too. I'm like ready for this. But it also gets you to think about, what does it mean to be expressing things and have something that you're wearing? What kinds of different concepts do you have about things that you wear versus things you leave on a desk or in your house? So it takes on a very different cultural position. Then we have our friend Vannevar Bush, who basically described you for this piece. You might have come across in other classes. It's a well-known sort of research project that it was a vision statement really coming out of World War II. So there was obviously a huge effort around technology push during the war, and they said, wait, what are we going to do now? We're just going to build nuclear weapons? What are we going to do? And he said, actually, we should start really a leadership around technology. In fact, we should have a whole foundation to really push the efforts of technology in the country. And that was the start of the National Science Foundation. It really came out of this work and this individual and some other people. But really the idea was one of those early statements, and this was a written piece saying that maybe we would have technology in the future that we would wear, and it would watch what we do, and it would augment us and do different things. This is a little quote from what the vision was, 1945, a long time ago. The camera, they have these strange terminologies. The camera hound of the future wears on his forehead a lump of little larger than a walnut. The lens is of universal focus. There is a built-in photocell which automatically adjusts exposure for a wide range of illumination. The cord, they weren't really into the wireless thing yet. The cord which trips its shutter may reach down a man's sleeve. I don't know why it's only for men, but it's whatever the vision of the time. With easy reach of his fingernails, a quick squeeze and the picture is taken. So there was still a lot of manualness. The vision wasn't that you would just sort of wear this. It was right. And then we saw this sort of Damocles from the first class, where I was showing some video of this in action. You'll remember this is this early augmented reality, but it was thinking about what would you do if you start to wear things. So a lot of thinking about where it would attach. Do you wear it on your hip? Do you wear it on your shoulders? Do you wear it on your eyes? So this is a lot about the eyes and what would happen if you could have something you carry around. And this was from the folks, again, that became part of a research unit at PARC, the Palo Alto Research Lab. So again, you should always, when you're looking at technologies, you certainly want to think about the actual bits and pieces that enable this. So what kinds of new scientific advances, but also where can we look for vision about computing and interaction with the body? So one might be literature. So Ray Bradbury wrote a lot of books. One of them, Illustrated Man, talked about how the tattoos or some kind of markings on the body could actually be part of a narrative storytelling. So how can our body be also part of an engagement with some other kinds of interaction? So a lot of times we think it has to be through a device. It could be through something that's on the skin. Similarly, for those of you that are Hitchhiker Guide to the Galaxy fans, there was the Babelfish, which was this device. He would it was a wearable device that translated different languages, and there's the actual schematic for how to make it. You can do that for extra credit.
It's just not casting the screen, it's only casting the camera.
Oh, okay. You don't want to see that, that's no good. All right, I think it's, do you want to test it now? I mean, I think it's this screen sharing. I think it's doing the, all right. Sorry about that, guys. And it's also fun to look at all these different movies, right? So this was the early envisionment came out of, this is the second Back to the Future, which kind of hit it, right? People sitting around the table, not paying attention to each other while they're eating, playing games. You could almost take this picture at other people's houses now. And then we saw things about augmenting human ability, either through, this is like obviously Jurassic Park, where you can kind of have these night vision. You can see things, well, what would that mean? Well, we kind of have that, right? So we have these technologies. But let's go back to the research labs and what was going on. So in terms of looking at academic and industrial research, this was a very early project at CMU, the ViewMan 1. This is someone wearing it, 1991. And this was largely looked at as, well, if you could take a computer on the go, this is a radically small computer, what would you do? The application was kind of remote repair. Someone would kind of guide you through some repair or inspection task. Oh, so just, I wrote down here in the notes, this had less than ½ megabyte of RAM in it, I think. All right. Now, one of the early things that came up with wearable computing, there was a huge shift. So think about, people were talking about computers. They're sitting mainly in offices. There's an offset group that's hanging out saying, you know, maybe you would have these in the home, but we don't know what you would really do with this. I don't know how many spreadsheets you can do at home until you just don't need that anymore. And then, yeah, of course, we've got, you know, Marvin Minsky and company going, well, maybe these aren't about calculations. There's a lot of discussions going on. But this idea about, wait, if you're carrying the computer, you're using it in a really different context. So maybe it is aware of what you're doing. So it is aware that you were on the bus, that you were in motion, that you're in a meeting, you're not in a meeting, all these different things. And so this was a big push in the early 90s. This is a quote from Anin Day, who's faculty at Carnegie Mellon. He was one of the early people to talk a lot about this. Any information that can be used to characterize the situation of an entity. So you're well aware of this. It's why, you know, based on time, location, other data about your schedule, to do the bad thing again. Oh, try now. Maybe that wasn't in all the way.
No, it's because go to Hangouts. You have to explicitly change your audio source.
Oh, I told it to do that.
Okay, that's good. That should be good.
Okay. All right, sorry. Okay, so this is a really early version of that. And this was, again, you see our friends popping up. This is, again, from Xerox PARC, Palo Alto Research Center, basically, or lab. This CSL stands for Computer Science Lab. That's the division inside. They made something called, this is the PARC badge. Right before that, there was the Olivetti badge. This was by Olivetti and some of the people. They closed down that research group and they folded it into PARC. What do you think this badge was used for? 1990, they made this badge. It's wearable. What would you use this for? What's like the challenge that they were trying to, what do you think they're trying to do? Or what it senses or anything? To get into a building, so to figure out like who it is, basically, to identify people. Yeah. Okay. Close. It's not exactly right, but that's on the right track. It is about somewhat identifying people. That's true. Here's someone wearing it, looking cool. What do you think that was used for? Gotta have some other guesses. Paging people. Ah, that's darn close. Okay, I'm gonna let that be full credit. Yeah, that's pretty close. It was a challenge. Here's what happened. I know this. You have to really go back with me. Someone would call. I know, calling, but work with me. They would call and they go, "We're trying to reach Professor Pauls," and they go, "I don't know where he's at," and they'd try to figure out what room you're in. But now the call would come in. The badge knew what room you were in, and the phone would ring in the room you were standing in, and it was for you. hello, this is the future. So they had unique IR beacons in every room, and the badge would detect the IR beacon, and it could tell what room you were in. You were sort of broadcasting this. And so it was like magic that I would run downstairs, and then you would try to call me, and it wouldn't ring here, it would ring downstairs. So the context, it was this amazing thing. Nobody had this. 1991, nobody could do this. There was no way to do this. So another sort of key player in this is this individual who basically came, this is Mark Weiser, who was basically the individual that came up with the idea around ubiquitous computing. So he said very similarly, like, wait, computers, again, you're using them in these contexts. Wait, what if a computer was kind of everywhere? Like, what do you mean? Like in the table? Yes, in the floor? Yes, like in the planter? Yeah, computers could be every place. They would be ubiquitous. Wait, you mean like Internet of Things? Oh, they'll use that term 30 years from now. But let me tell you about it now. So he already had this idea like 30 years ago, and he basically told us about it. And he also said, you know, I think there's going to be 3 different platforms that you'll use for computing that are not like these desktops and keyboards you're using. And I think they're these 3: pads, tabs, and boards. So here's a pad, or tab, this is a tab. Pad, I don't think I have to tell you what a pad is, and a board. And there he is in 1991 showing you what the future would look like using these things that people thought, what would you do with a tab? What the heck do you keep on a tab? How do you compute on something like this? What the heck do you do? So there is pad, tabs, and boards, and the Olivetti badge, which became the Park badge, was part of this because they started to respond to the environment and the context of usage. And so he was really another visionary that really pushed the field forward in thinking about that space and what we would use. So back to wearables. Here we are. So we're back at the Media Lab. Actually, in relation to today, Marvin Minsky was there at the time, and these characters were roaming around the wearable computing group. Why are we not wearing this today? Seems like we should. Looks good. Looks comfortable. What happened? So this group was very much about we're on the edge. We're going to actually wear this and live our lives and compute fully on the go. So they actually see a screen in front of them, and they're interacting and moving around. They tried to get a slightly more, like, less ominous picture here the photographer took. And they started to explore what it meant to have context computing. And one of the, Brad Rhodes, who's in the purple there, he wrote a lot about this. He talked about that experience, and he said, let me tell you about the wearable characteristics, what kind of makes this unique and where the kind of opportunities are. That it's portable while remaining, you have to think about, nobody had this at the time. This is the only devices that did this. You all carry things that do this, but at the time, portable while remaining operational, thereby allowing a user to move and still operate the device. Radical 1, that didn't really exist. 2, allow for hands-free use and allow for non-obstructive access. That was really difficult. Integrate sensors such as wireless communication, cameras, GPS, microphones, and other accelerometers as input devices to provide information about the close environment. Again, like the context, what's around. Communicate information to the user in a proactive way, thus conveying information to the user even when not being actively used. So the idea is before you have to turn it on and go, well, I don't know, what is the temperature? What floor am I on? It would just monitor these things for you. An example would be alerting the user when new emails arrive. So it would just alert you to that. And always being on, continuously receiving information about the surrounding environment. So back to these folks. So here's Steve Mann. He was one of the individuals that actually was in the beginning of this movement. He was in both of the previous photos. Actually, I think alert mode, he's coming to Berkeley soon, so you may spot him on campus. He just sent me a message that he might come by here, so you might see him, although he's not in this kind of a getup anymore. But you can ask him about these days. He came to visit me once many years ago in kind of the like middle version getup, And he came in my house and he did this. It was like, you can't scan people's houses, Steve. This is very weird. Don't do that. I proceeded to take him out in San Francisco and sit him in the most public places possible and watch what happened. So anyway, let's go back to the story about Wearable. So people thought it was really focused around the glasses and the eyes, right? So we know this. Feels like modern times. There we got it. Smaller, computing, Moore's Law caught up, everything. So here's Google Glass 2013. Did you catch this guy before? That's Thad Starner from the earlier photo. Do you recognize him? He's been at this for decades. He did this as a grad student at MIT, he did it at Georgia Tech, and he led the Glass team. So he's had this long history of working on these projects. And of course, now we have all kinds of wearable devices. Okay, so we can sit there. This was just me Googling a couple nights ago wearable technology and all the kinds of different things that came up. This is what at least Google tells me that it is. This is me visiting Thad recently. He's down at Google doing all kinds of different devices. He was wearing something else at the time, and I said, "Can I take a picture?" He goes, "Oh, not with this on. I have to change. I can't have this released." So he put some other thing on. But I want to point out that sometimes these things look really ridiculous, and he saw the vision of where it needed to be, and he's pushed on it, and he knew the right kind of decisions to make from an HCI standpoint and from sort of an engineering standpoint. So this also, we know it's not an extremely successful product. So what happened with this? What were some of the things that kind of came out? Right, privacy. It was very awkward to sort of stand in front of someone. You didn't know what they were doing, right? Not fashionable. This is true. Even though it's come a long way, it's not super fashionable. So attention to having something feel fashionable, that's a big part of this. Yeah, what was it, $1,300 or something? Yeah, so not really low cost, although most of these are always early adopter things. So sometimes people say, I'm not buying one of those, smartwatches. They're like $400. Like, they're gonna be so cheap, it's gonna be, all right. Oh, that's true. Limited availability, they're hard to get. That's because they released them in a very strange way. I meant, okay, yeah. Eye strain, oh, right, because you have to change your focal distance when you're using it to see the screen on there. Yeah, I'll try to bring one to class next time. You can try it on and check it out if you haven't used one, just to get a sense, so at least you know what that experience was. Okay, let's go. We brainstorm. So let's go wide on this wearable story. Here's a wearable. So tracking devices, there was actually some research into this about, tracking. Here's more of an ingestible, but we'll put it under slight wearable, these bio patches and things you put on your body on the epidermis. Here's a wearable that you wear in your mouth, basically. I don't know, for any of you that wore a retainer or something when you were younger, and I know, you don't have to confess it now, there are some days you didn't wear it. This retainer tracks that. Eric Paulos did not wear his retainer today. Here's some ingestibles, so things that are computing in the body, right? So this is one that's got some different sensors that you actually ingest, and they have different chemical sensors on it. This is some work. Some of it actually, okay, so there's also things on the body in terms of building electronics on the body for computing, sensing, actuation. So you can imagine you will be, this is, I'm just gonna put you, here's you in the future. When I was a kid, it was just a regular Band-Aid. It didn't have any of that fancy computer stuff in it, right? So You will have Band-Aids that help you heal, report what's going on, all these kinds of new sensing opportunities. And some of this goes on at Berkeley. This is actually some work by Joanne Lowe, one of my grad students, where she's doing things with tattoos, temporary tattoos, and making electronics so that I'll show you a little plugged video here about it. So you can actually, there's an aesthetic quality to it, so you can wear these and it sort of responds to sounds and things, but it also means that your skin can actually be part of the kind of interactive experience. So you can actually use it as a touch sensor, and it uses this very basic sort of silk screening process. You can play games basically on your skin now. You can make phone calls and access things. You don't need to have a watch. The watch is very old school. We just use our skin now. And we can do sort of strain gauges, so we can tell some basic body movement and where you're touching. You can send secret messages to your friend. You can sense other things. It's a heartbeat sort of sense. Okay. So there's also some work that we've collaborated with on some new textiles. So right now, like clothing is very much a wearable. You basically, I think most of you chose some clothes for today and you kind of stuck with that, right? You're not sort of changing your clothes every couple minutes. But we're imagining if you could actually have technology that would actually change, so you could actually create these experiences where the textile actually, you can output information on it. So it's just changing properties with the actual fabric material. Just we can do it in a controlled way to create these other effects that you would have on clothing. So again, maybe in the future it'll be, oh my gosh, I have that job interview to go to. I better change my shirt. Looks good. Good to go. Okay. All right. All right. So this is some project again by a bunch of grad students. Joanne and a number of others. Laura, who's from the iSchool, and Nora Howe as well. All right. Wearables. Let's go broad. So this is Stellark. He's a performance artist who decided that he needed a third ear. So he actually had this ear made and implanted under his skin. It has Bluetooth so that you can actually speak and whisper into it, and he can hear in your ear very quietly. So think about not just what the body affords, but other ways that you might. I'm not suggesting everyone goes and adds an ear to their body, but I will tell you one other personal anecdote. Stellark, so he came to my house when I was in Pittsburgh, hung out with me for dinner. My family was there. My kid went to school the next day, and he said, they called me. They said, your kid keeps talking about a guy with a third ear. You need to come pick him up. Something weird is going on. I go, no. There is the guy with the third ear. So that's my son with him. So I convinced them through this photo that indeed this was the man with the third ear. So this is, I'm gonna do a little bit of landscaping so we can get back to watches. So Hugh Hare at the Media Lab. So this is different kind of wearable. He was injured in a climbing accident, and he has prosthetics, and he is sort of designed them to give him kind of super abilities, to have more kinds of ways of moving or have superpowers now. So it's another way to think about augmenting through these technologies. Anyone that's on these kind of hacking sites, I think on Adafruit every Wednesday is Wearable Wednesday Day, and people throw up little ideas. I think these were some shoes. There were some shoes someone made in my critical making class a couple years ago that were BFF shoes. So when you're near your BFF, they kind of lit up and did cool things, but not when you're with your not BFF. So it's like, check it out. Right, so context aware. So iWriters, this is a famous graffiti artist that was injured and paralyzed. And this was a low-cost technology that he could wear and do his graffiti art through this technology. So enabling people, also looking at people's abilities or disabilities and augmenting them. There's also things around designing for safety. This was a technology that's a new kind of bicycle helmet that looks super cool, and the moment it detects you falling, it inflates, and there you go. So let's try to go back to smartwatches. I just wanted to make sure that we didn't talk the whole time about watches, because then everyone will obsess about the wrist. When we talk about wearable technology, it's in a lot of different landscapes. So let's jump in at 1972. This was the first digital watch. Look at how awesome. Pulsar P1. There it is. Awesome. Now, what happened? Quickly, more electronics went into it. So we saw people start to add, there it is, the first calculator watch, the C80. I was not cool / nerdy enough to get one of these, but there it is in 1980. You could now actually touch it. Now, what's the obvious problem with this? Right, the fat finger problem is already a problem in 1980. It's already coming up. Problem, very hard to hit those little buttons. So now what if we had a way to connect that to a printer, and we could print out stuff and we could transmit things? So this was an early device that Pulsar had 24 bytes of RAM, and Seiko made this in 1982. It had a thermal printer and a cool dock, and here it is kind of in the dock because you dock your watch. So if you really want to be retro, you go, look, I got the cool Seiko dock, man, check it out. So now they're trying to work around the fat finger problem. You can see how designers are like, people are having trouble typing things in. We need to do something. This is kind of a hack. They're saying, well, our answer will be, don't do that on the watch. Do it on this other device, and then it's on the watch. So similarly with this, you could actually attach this to a Commodore 64 or an Apple computer at the time, had about 2 kilobytes of RAM, and you would actually transmit. You could now kind of bring things off your computer, little data. This was one of the first devices that used a touch screen. So now the buttons have gone from being disconnected. You actually touch on the screen, and you can sort of program it. In 1984, this interesting device came out. I wish I could get a hold of one of these. This is the Casio AT550-7. I don't know who's in charge of the naming scheme, but it's a real problem. This watch did something that was so ahead of its time that it just blows me away.
So this is a Casio AT550 watch. It's a digital calculator. The entire screen is a touch screen. So I'll just draw a 1 to enter a 1 into the calculator. Now I'll draw a 7. Now I've got 17. Now I'll draw a plus sign. And now I'll draw a 3. And now I'll do an equal sign. And lo and behold, 17 plus 3 equals 20. Key thing is, I can do this with my finger without looking at the screen.
Awesome. 84. That's pretty amazing. Now you notice the last comment. So as an interaction designer, pay attention to that. Before, you'd have to look at the screen. You have to look, what button am I hitting? With that, you can sketch out a number. You just need to know if you're on contact with the device. But that's a huge difference, right? Your attention can be on someone else. Let me add this. 35, 27, yeah, 382, right? So that's a big leap in terms of the way the technology works. So watches started to get a little bit more connected with wireless messaging systems. This doubled as a pager. I know no one has pagers now. Obviously, we can see Moore's law in effect because we've got more computational power. This actually let you program little apps in C. So this is kind of the first watch you could program. So you could actually write little code snippets and upload it to this watch and run them. And then if you wanted to program, this one had a kind of Linux OS really stripped down on it that you would be able to program as well. And you can see a sort of struggle of size, screen size, where the input is it on the screen, is it on through these other buttons, things like that. Microsoft came out with this watch that was really a one-way communication that let you know, it could receive basically, this will tell you how poor the wireless coverage was at the time. It used sort of AM and FM radio. It looked for messages that were text kind of in between the band gap, and it would then get information about when you landed in Seattle, it would say, oh, the weather in Seattle is such and such. And then you land in San Francisco and it'd go, oh, something like that. Were you gonna say, yeah? Oh yeah, so back to the cool watch with the touch screen. So I think it was mainly a cost. It was pretty expensive, and the marketing, it made it, the design felt very business oriented. Imagine if they made that for kids or for a classroom, or if that was, also if it had fun other things, like you made a shape and it played a funny sound. You'd be like, wow, right? You could do funny, there's a lot of other things you could have done with it. But I think it was just, at the time, people were struggling with the idea of why do you even want a calculator at all? Why are you carrying that around? People were still grappling with that. So the application space was poorly defined. It was all about, almost all of those first few were about calculations. Only these later ones you're starting to see, what if you got the weather? What if you got messages? What if you could look up phone numbers? But that interaction model is really unique because it means you can still have it look like a watch and then have a way to access other features, kind of you can reveal them in some sense. But I think it was largely, I don't remember the cost, but it was pretty expensive, and the marketing, I mean, those watches were marketed so poorly as these kind of, do you want to be the successful business person? Like, you should have this watch. Like, yeah, and that example, I mean, that's actually, so that example, there's a famous HCI researcher that has been really smart and bought almost all this stuff, and that's him doing a demo of it. So one time he broke out his whole collection, and it was like amazing. It's like 3 rooms like this full of that kind of stuff, all operational. It's really cool. Yeah, good question. So we're getting a little bit closer, 2009. Maybe you guys probably don't remember these, but these were starting to kind of emerge. There was a watch, there was a phone as well. It was the first time you kind of had something you could talk as well. And then, I don't know if this really qualifies, people started to jam the Nano into a watch face. It's not clear if that's actually counts, but we'll put it in there. But clearly the trend went to, there was a huge explosion right around 2011, 2012, Fitbit started to emerge, and Fitbit and all these devices, right? There's so many different ones. So wearables took on a form that all of a sudden they had a different application. People said, wait, forget about adding, forget the screen altogether. Let's just concentrate on one single thing, activity. Let's try to figure out what people are doing with activity. We'll measure that. Maybe it tells the time. They try to minimize rather than have it do all of these functions and features. Then I think people remember Pebble, maybe. This is an early watch that came out. It was a big successful Kickstarter, which got all these companies to say, wait, smartwatches? People want this? And people are like, yes, this is amazing. It has this great screen. We're excited about it. It had e-ink display and all of this technology. So finally the power curve and the amount of processing were getting close to matching. And then I could literally show 10,000 slides of all the things that came out in the last 2 years. I'll just point to a couple. We had a bunch of things at the Samsung Galaxy Gear. Obviously Android said we're going to do Android Wear, and they sort of supported a large number of devices. Some of them I'll be giving you in the next couple of weeks. There's a bunch of different types of styles and different devices, some with worse battery life than others. We had the kind of instance of when I taught this class in 2014, this product came out mid-semester, so we kind of suddenly this emerged and we're like, yes, watches are even bigger. I pulled a slide from that semester. This is what people, right before the Apple Watch came out, they said, this is coming. This is the designs they thought it would look like. And you start to see really poorly thought out things like, why would we slide to unlock? Why do you think that is a thing we want? So it's just interesting, you quickly forget, but when people were trying to imagine, they knew an Apple Watch was coming, they just didn't know, they were speculating. Some of them obviously a little bit of tongue in cheek, but what would it look like? How radical would it be? So I'll tell you one other story about some wearable technology. This is something I was more personally involved in. So when I left Berkeley after grad school, I went to Intel Research. And one of the first projects I did there in 2001 is I said, well, what if you could measure, I wonder how people communicate when they're not talking. Like how do they do that? And at that time, barely was emerging things like emojis. That was kind of an interesting thing. And it was, well, we went to a farmer's market, much like the study that you're doing, you're going out to watch people. So I went out and watched people at a farmer's market, and I watched how do people communicate without talking. So I'm looking at like, how do they touch each other? Do they have eye glances? Do they gesture? And at the time we had a piece of technology, these little wireless sensor motes. So they were used to basically measure environmental conditions, and they were used to kind of monitor low networking kind of simulations and how people do multi-hop routing and such. But we took that and I said, well, what if we built a watch that sensed things like, I don't know, you could tap on it, maybe it had these other sensors and it communicated things. So back from that time, this was like me looking a little weird and how weird Intel marketing, but the idea was maybe you'd have this watch, you would tap on it, and then the other person would feel you tapping on the other end. And likewise, maybe you could actually kind of stroke it and it would also similarly give a signal to the other person. And finally, you could hold it and it would capture your heartbeat and send the heartbeat to the other person. So that was, yeah. Trivia note, that is my wife. We weren't married at the time. I convinced her to be in the video, and then now we're married and have 2 kids. So things can work out. So, as you know, that's obviously a lot of stuff that's going on now. That's exactly the real touch. So the reason I tell you this is that basically when I did that project, people said, this is stupid. Stop doing this. This is really dumb. Nobody wants to send weird tapping signals. No one wants to send heartbeats. That makes no sense to me. Do real stuff that really matters. So it was a huge redemption when this came out, and I had this awesome day, all these people saying, aha, wait. So I'm just saying, try to remember that little anecdote in your own experience when someone says this is a bad idea. And if you really believe in it, you know, go, listen, I bet you in 12, 13 years, some major company will really do this. So that was very cool. I don't make any money off that, so don't think I'm trying to plug that, but it was really cool. I still want to like ask Johnny Ives about it sometime. So, opportunities for smartwatches. So let's look at some of them. The experience of retrieving information was the key principle driving information access through a device. So this is some results from a study where they looked and observed and watched what's going on, what do people find value about this experience. The user experience was affected by how users can control their personal flow of information. So you can get this like too much, not good, or if you can't throttle it, or if you can't control it in the right context. Sensor data based on user context and information accessibility. Smartwatches that satisfy user requirements more adequately will survive. Smartwatch interfaces have been predicted to replace the smartphone for simple tasks, so viewing short text and accessing sensory data. This has already sort of happened. The UI with the watch involving flexible input and rapid text entry are vital. It's very hard to do text entry, right? So what do people do now? It's mostly voice, right? What's the problem with voice? Hey Siri, I can't text during lecture. Yeah, it's hard to text. It's it's a public experience. Hey Siri, remind me about that weird rash that I have. Oops. right? It creates a very different public perception. What else about voice interfaces? Noise, right? So very difficult to do in a crowded situation. Oh, right. Okay. So yeah. So there could be, rather than actually making the sound, you can do muscle motions, or you can basically mimic what you would do without moving air through. Yeah. So you can. There are other ways to. Mhm. Right. So you just go. Okay, I got it. Right. So that kind of thing. That's right. So you could use this as smart, thinking about other sensors, other ways to get around these issues. Voice is here. It will stay with us. I'm not saying it's going away. I'm just, you should be aware of the places it doesn't work. How about from an HCI standpoint? What's a thing about once you give someone that voice UI, what happens? Or maybe something else. Right. Oh, to listen? You mean like this? Oh. Oh, well, yeah, there's also the public of, you know, my wife sends me a message, I might look at it. I don't want to play it for everybody to listen to, right? Yeah. So when you give someone some experience like voice control, we talked a little bit about this, about how we use those metaphors. So if you show someone the calendar that has that little, you know, rings, and we say, well, that, yeah. Oh, you don't know if it received what you're, is that? Oh, you can't, I'm not, okay, so the feedback of what it's recording, or? Oh, for listening to things. Right. Well, there's a little bit of, there's an asymmetry. It's often easier to read something, a bunch of text, than listen to it. You've had this experience where your friend calls you, like, hey, good to call. It's like, we're, get to the point. What's going on? You want to scroll the end of the message. Oh, 4:30 Strata, I got it. Right. So one is, you often start to treat it, I mean, it's talking to you, maybe. I mean, we have a little bit of a debate of what's coming back, but once it's conversational, then you think and have the expectation that it should also know what you're talking about. Whereas what you're kind of alluding to is there's only like a set, you sort of end up being sort of slave to the machine in some sense. You know, how many times you've gone, oh, remind me to go to the, like, you know, oh, reminder, 2:30 Wednesday, right? You have to kind of mimic this very computational way of talking. And that happened with some other bits of technology with user input that we get to later in the semester. But that's a good point. I think the point I wanted to also make was, when we talked last class about how people basically looked at a metaphor like that calendar, and they thought, and you could imagine, well, then it implies that maybe you can rip it apart and take it over and do these different actions. The same thing, voice people infer that you can also have a conversation, get more information, when I think all of you as computer scientists know what's going on the back end, and there's a limited kind of vocabulary, there's a limited set. So voice had been around for a while. In fact, even back to the earlier reference with Marvin Minsky, Stanley Kubrick came to him when he did 2001: A Space Odyssey and said, do you think that computers will talk around 2001? He's like, yeah. So it was like his consultation, but the idea that you could, the conversations are not as rich as you would expect. So that was part of the downfall. So some insights which you're well aware of is now you can kind of flip these things on. They're really easy to kind of on and off. You can talk to your watch. We've talked a little bit about why that's good and bad. They can interface with phones to do heavier lifting, but they might interface with tattoos or clothing or shoes or other things, which makes it a little complicated, because then you rush off to class and you're like, did I wear the right ensemble of electronics today to talk to everything? Touch gestures and shortcuts, on-body kind of sensing, new kinds of messaging. And then there's the wrong designs. So people kind of showing, oh, look what you can do with your smartwatch. Like, nobody wants to do that. I promise you. And all the challenges we already know about that keep coming up. The screen size, they're really small. The fat finger problem, it's hard for legibility. The privacy issue, other people seeing what's going on. Power, mostly that's the engineering challenge. How connected they are to other things near you or your phone or the body or the network. Other kinds of sensing, what the kind of input and output mechanisms are. And also fashion, social acceptance. So which is cooler, this watch or this watch? It's cool. So we're going to be using the Moto 360, as I mentioned in the first class, and this is kind of the specs on it, so to speak. It has some challenges because it's this interesting form factor. It's circular, backlight, it has a pedometer, has a heart rate monitor, has some physical buttons of vibration, some other things. So there's some definite landscape to explore on what you do with this particular design. Let me give you a little insight into some future interactions with wearables, particularly around things on the wrist.
From a Sonova smartphone.
Hi, I'm Chris Harrison, and I'm going to talk about abracadabra, an input technique.
I'm going to show only one thing, this one.
Many everyday electromechanical objects emit small amounts of electromagnetic noise during regular operation. Typically, these electromagnetic signals, or EM, are low power and outside the regulated frequency spectrum. They are also distinctive and can be used to classify objects.
This is from only a couple months ago.
When a user makes physical contact with such an object, the EM signal propagates through the user. We can detect and classify EM signals in real time, enabling quick and robust detection of when an object is touched and what that object is. We call our approach M-Sense and have built it into a prototype smartwatch. We explored 5 example contexts and environments. For example, the home, office, a workshop, transportation, and in general, large structural features. By recognizing objects, M-Sense can augment activities across an entire day. Here, the user is brushing his teeth, which automatically starts a timer. When the user steps on an electronic weighing scale, data is captured and displayed. In the kitchen, by detecting patterns of appliance touches, we can infer the user is cooking breakfast.
From NPR News in Washington, I'm Jim.
When the user arrives at the office and opens his door, he can be notified about calendar events and waiting messages.
You have 12 messages and a meeting in 12 minutes.
Similarly, he can create reminders which can be played back at a specific time of the day.
Remind me to pick up the milk on my way home.
In the workshop, M-Sense can assist fabrication activities.
5 minutes left before printing complete. Time to print the wood base.
Next, a Dremel is used to cut a piece of wood. The speed is indicated on the user's watch. When the user operates the drill, the tutorial automatically advances and an instructional diagram is displayed. To finish the wood piece, a sander is used. Again, the instructions are automatically advanced. Finally, the 3D print is done, and the pieces are fitted together. Back at his desk, the user continues work on his laptop. Because the laptop knows a user is touching it, and the smartwatch knows the user is touching a laptop, the user can be automatically logged in. In collaborative tasks, MSense can be used for differentiating between users, identifying them at the moment of touch. For example, users can annotate in different colors, with the smartwatch providing a personal color selector. At the end of the day, the user closes his office door. The reminder he left earlier is now played.
Don't forget to pick up the milk.
MSense can detect a user's mode of transportation,
You are 10 minutes from home.
which can be used to provide additional relevant information. In summary, MSense can detect a wide range of objects, which allows for automatically launching context-based applications.
Okay, so there's some future direction. So great work. Only critique, I'm a big fan of Italian motorcycles, so I have a little problem with that at the end. But other than that, we'll let it go. So we'll see you basically next week. Remember, section this week is going to be going through more of the designs for smartwatches. They're also going to give you some tips on how to interview people if you're struggling with that design assignment. All right, thanks everyone.